I'm Frank Bosco. In this talk, I'm going to argue that scientists should use controlled vocabularies like taxonomies to standardize their research findings. A quick outline, I'm going to start by discussing the metaBUS project and how it uses a taxonomy to facilitate meta-analysis. I'll then discuss considerations for the construction of the taxonomy and thoughts we had along the way. And I'll end with some thoughts about the future and what could taxonomies do for us for our research findings in the future. Okay, so why does metaBUS exist? This is a very typical abstract from an applied psychology journal. I've underlined the 5 constructs that are in that abstract. And if you were to look at just that abstract, this is what you would expect to be in the paper. You would expect to find 10 correlations among those 5 constructs. But in reality, matrices tend to contain much, much more information. So in this case, actually 87% of those findings that are in that matrix, you wouldn't have known exist unless you went past the abstract, okay? So we realized there was a great opportunity here. If we could find a way to at least semi-automate the extraction of these matrices and put them into a database, we could do a lot of interesting things with them, right? So there's more details available on the actual process at the link, the YouTube link there. But in a very general sense, what we do is we find ways with PDF extraction to take a correlation matrix and to turn it into a database format. The database, in a sense, has multiple levels. So here I'm highlighting the so-called variable level. These are the names of the constructs or variables that you see in the matrix. And then there's also an effect size level, which represent pairs of those constructs or pairs of those variables, okay? And so for every possible combination of construct names or variable names, you have one row in the effect size level database, which contains your correlation value and so on and so forth, okay? So what we do is we semi-automate the extraction of the information from the matrix, and then we manually code a bunch of different information about each of the variables. So for example, for every variable in roughly 17,000 papers, we know the data collection country, we know the response rate, we know who provided the data, whether that was students, whether it was supervisors or subordinates, to whom the data pertain, and so on and so forth. I don't have time to talk about all of these different things, but there's a human resource management review paper that describes the database structure. So I'm going to show you 2 different ways to search metaBUS. I'm going to show you how to go about using letter strings, and then I'm going to show you why that's a flawed approach, and I'm going to show you what taxonomy allows us to do and how it facilitates the location of research findings. So this is our interface that allows us to run a targeted search. Basically, what you're doing is you're specifying 2 separate variable names or construct names, and you're looking for all possible matches in the database, and then we're going to churn those data through basically an instant meta-analysis machine. So I'm going to use an example here of, let's do pay satisfaction, and let's do turnover intention. I'm just going to type turnover intent, and I'm going to hit run query. So what's happening, like I said, we're pinging Amazon Web Services. We're going to run that query and bring the information back. And what's just happened is it's located 23 findings, 23 effect sizes, and it's done an instant meta-analysis for you on those 23 effects. And it's telling you that the mean correlation is a -0.3. So in other words, as pay satisfaction goes up, turnover intention goes down, which I suppose is not that surprising. But notice that there were 23 findings found. Now, let me go back to my slides for a second. One of the problems with letter strings, unfortunately, is that it tends to yield many false positives. That depends on the search term you're using. If you're using the word age, for example, you're going to wind up getting a lot of false positives for things like engagement and management, right? Another concern is that there's virtually no standardization of the terms that we use when we're referring to our constructs and our variables in our matrices. So I've actually located a paper that, rather than calling it turnover intention or quit intention, used the phrase in the correlation matrix, the conviction of decision to quit. So these things happen on a regular basis. And in fact, if you look over on the right at table 3, that's also from a human resource management review paper, we located in our database more than 100, or maybe more than 150 unique variable names, all referring to turnover intention, right? And employee performance, I think, is an even greater problem. Employee performance goes by hundreds of names, and it's one of our most studied topics. Another issue that we see regularly is mislabeling of variables in matrices. So for example, sometimes an individual will study turnover intention, and they'll report it in the matrix as turnover, which are very different things. Turnover is a behavior. Turnover intention is essentially a questionnaire response, right? So let me show you how metaBUS gets around this problem, all these different variants, all these different language variants. Okay, so in the interface, you can click on Explore Taxonomy, and you can search the taxonomy too. So I'm going to type in the word quit, okay? And what it's going to do is it's going to highlight everywhere you might find a match for quit downstream. I'm going to turn that off for now just so you can see everything. But I'm interested in intentions, employment intentions, quit intentions. So we have 13,600 or so findings with turnover intention and something else, okay? And if you're curious, you can open these nodes and you can see what other naming variants there are. Okay, so for example, intentions to leave, intent to leave job, intentions to quit, et cetera, considering exit. But what I can do in metaBUS is I can use that 5-digit identifier, 20179, and I can search the database relying on that. Now keep in mind, these were assigned at the time of article coding manually by the people who collect data for the project. So I'm going to go back here and I'm going to add 20179. And we're going to see if we can find more than 23 effect sizes. So I'm going to go ahead and run the query again. And now we have 41 effect sizes, okay? And if you scroll down, you can see why. So intent to quit would not have been captured by the letter string turnover intent, okay? Now, in the case of turnover, there's only a few words. There's quit, there's leave, there's exit. And of course, there's turnover. But in the case of performance, we're talking hundreds and hundreds of different name variants. Okay, so without some kind of a taxonomic classification, it's quite difficult to come up with all those possible search terms. Okay, all right, let me go back to our slides. So one of the issues we encountered as we were constructing the taxonomy was what sort of taxonomy should we be constructing? We ultimately decided on what KnISE calls a generic taxonomy. That basically means that all paths in your taxonomy have to be true ISA links. So let me give you an example of one that's not a true taxonomy or not a true generic taxonomy. This is a paper from 2008, Cassiona Guinness's content analysis of topics published in Journal of Applied Psych and Personnel Psych over a few decades. And you'll notice that they have personality assessment listed as a child of predictors of performance. The reason that's not a true generic taxonomy is that personality assessment is used for other purposes besides predicting performance. It's used to predict turnover. It's used to predict a variety of other things. And so therefore, this cannot be a true generic taxonomy. On the other hand, this one is. So if you look at the path here, personality is a trait. Traits are psychological in nature. Psychological things are person characteristics. And I believe those statements are always true. And that's kind of the test, the litmus test for a generic taxonomy. Well, that doesn't necessarily mean there's only one way to construct this taxonomy, right? So for example, if you look at the taxonomy, you'll notice major construct classes called attitudes, behaviors, intentions, and so on. And we tried to eliminate theory as much as possible from the construction of the taxonomy, but even there's some inherent theoretical mechanism, right? I mean, you're probably thinking the theory of planned behavior, reasoned action, intentions, attitudes, behaviors. We could have instead constructed the taxonomy based on how things are measured. So in other words, one of the very first branches could have been self-report questionnaire responses. And I guess technically you would expect to find personality downstream and even all kinds of job or work attitudes, right? You could have objective indicators of behavior, and that would include productivity measures of performance and turnover, and so on and so forth. Another consideration is whether or not you should increase the complexity of the taxonomy or simply add a tag to it, which essentially represents a database field, right? So for example, if you imagine performance, you can imagine performance and then in-role performance, and then you could potentially have subnodes there for manager and subordinate performance. Another option, which I show you below, is you could simply code that as in-role performance and then add a quote-unquote tag or database field that indexes basically who does this information pertain to. So we decided on the second approach. So we try to limit the complexity of the taxonomy, but yet it still has over 4,000 nodes. Okay. Sometimes, though, it makes sense, I think, to increase the complexity of the taxonomy. So several of the talks in this conference are going to be about improving measurement. One thing that would be great to have in this metaBUS taxonomy would be the specific measures used to measure each of the constructs. So now again, you could say, well, maybe that should be a tag, maybe that should be increased finer levels of the taxonomy. In my opinion, I'd prefer to have that as finer levels of the taxonomy, simply because there's so many possible options for all the different measures. And I'd rather have things work properly in a dropdown in Microsoft Excel when the data is collected. But at any rate, the information is still there and it can still be used, right? Another issue that we encountered was basically, how do you make everyone happy with the taxonomy's construction? And I don't think that'll ever happen. You're never going to satisfy everyone with any particular taxonomic arrangement. And in fact, taxonomies in general have been criticized in the sense that when you go about constructing a taxonomy, you don't really know whether you're classifying or creating a depiction of your own biases rather than the actual reality. So there are approaches you can use to validate a taxonomy, such as a Q-sort, but that could take a very long time when you have thousands of nodes. There could also potentially be an empirical approach to it, something like a dimension reduction approach. But I think that given the signal-to-noise ratio of our field, I'd be a little scared to see what that map would look like, what that taxonomy would look like. We might wind up with age and tenure as attitudes, or along with other attitudes. I don't think it would be very clean. So what about the future? I'd be interested to see how other sub-disciplines of psychology develop their own taxonomies for their use and what they can do for them, okay? And metaBUS, of course, offers the largest taxonomy that I'm aware of constructs in psychology, so that might be a good starting point for expansion. But in a larger sense, what is the future for the curation of research and the use of taxonomies? The first thing I would suggest, okay, so and a number of talks today are about AI. I'm going to go against the AI mainstream, and I'm going to say the first thing that we should do if we're interested in curating our research is to code the backlog of existing findings manually, to use absolutely no automation. Okay, so when you're classifying each construct according to the taxonomy, that should be done by humans. Unfortunately, I think in a variety of areas, we have a lot of research funding going towards similar projects, projects similar to metaBUS, and they're almost all focused on using some level of automation or artificial intelligence. The reason I think this is silly, and I mentioned this in an AMPPS paper recently, is that I think actually more funds have been spent generating these automated approaches that actually provide less reliable information, okay? And in reality, for this specific task, for coding a few million findings, which is really only manually coding, I don't know, maybe up to 1 million or 500,000 variable or construct level pieces of information, I think it would cost less to actually do it manually, and that more reliable information could in turn be used to train automated approaches. So in many ways, I think jumping right into an AI seat is putting the cart before the horse. We have to first get our data warehouse in order, and then we can train AI approaches on that, okay? Another option for the future would be to have researchers themselves code their own papers before publication. So if you imagine, if we could get to a point where we have the entire backlog manually coded, and then we have the authors of the research classifying the information in the articles themselves, that would potentially give us a richer, even more reliable database that could be used, again, to facilitate meta-analyses and for a variety of other purposes. Okay. And finally, I'd just like to say I really wish and I hope that funders in the future will realize the value of manually curated data. It really seems as though funding is going toward almost everything but that. There has to be some exciting AI component to get significant funds. I think it's very important that we prioritize the collection of data in a manual fashion. And again, in the future, that manually curated data could be used to train automated approaches. Thank you very much.